All right, welcome everyone to the January 2019 Elixir Nerves Remote Meetup. I think it's just supposed to be one of those, just Nerves Remote Meetup. Looks like tonight we're going to have a couple of us on the call. I have a little project that I can share. I put together some slides for about how to do a make-it-yourself like marquee with a big matrix of pixels. And so that's been kind of a fun project to work on. And then I think Jon also has a little project update on his desk and maybe a little bit of a walkthrough of that. Todd or Dennis, do either of you guys have anything that you've been working on recently you want to share?
Not me. I've been trying to build a prototype for my talk. Something I can bring with me on the plane.
Nice.
It's just sprinkler stuff.
Is your talk going to be in, is it Lone Star? Is that right? Nice. Awesome. Actually, I have a talk coming up in like a week and a half, MPEX. So still trying to get the last of my slides put together, but I'm done with all my prototypes. I am actually trying to build a little bit of a nicer, like mounting some of my components together. For the same reason, I don't want it to like all fall apart and then just have a bunch of wires when I unpack my bags in LA. Although I guess that wouldn't be the worst thing in the world, but yeah, just trying to put it together in something that's easy to like hold up in front of a group of people or whatever. So a little bit of work going into that. All right, should we just go ahead? I can just kick it off. I think my slides will be relatively quick. I think they're useful if anyone has wanted to build or interact, I should just say, with any sort of like strips of pixels or matrices of pixels. So I'll run through that real quick, and then and feel free to interrupt and just ask questions whenever.
Do you worry at all about taking it through TSA?
Yeah.
Just a bunch of random wires and everything.
Yeah, because the title of my talk is 5 Easy Nerves Projects. Yeah. And so there's 2 of them that I can't easily bring. I have a set of garage door sensors. I can't really bring garage doors. And I have a sprinkler controller. So those 2 will just be like pictures and stuff. But I do have 2 of them, like a touchscreen scenic game. And then also this pixel matrix or RGB LED matrix. And both of those are like, they're just going to have like some exposed wires and a couple of Raspberry Pis and probably extra power cords in case things break or whatever. And I'm sure, so I'll plan to get to the airport early so that I can get harassed and still make it there.
When I went to New Orleans, I had the same fears and spent a few hours researching it. Sorry, excuse me. I ended up taking my little Pi Zero. I basically decided the least number of components that if I had to throw it away, I wouldn't be totally distraught. So I took my Pi Zero, some wires, a few sensors, and with the mentality of like, if it's got to go, I can deal. And oh, I think my son's here. Yep, there's Legos in the background. Sorry. Yeah, and like they didn't even bat an eye. And when I went up and I was going to scan it, I even told the guy, he's like, "Do you have any computers or anything else in there?" Like a little Raspberry Pi Zero is and some wires. Is that going to be a problem? And he was like, "Only if you have Ubuntu on it." What? That was his response, you know. Props to him for knowing that. But
I'll keep my fingers crossed that I get that security guy.
So then when I was there, I was asking Justin, because I was relating the same story. He's like, "Yeah, man, I've been through with bags of just wires in a hard case and poking out everywhere, and they haven't even said anything." So that's what you got to hope for.
I mean, I'm glad to hear that, because I was thinking about it. I was like, well, they have all these different, like, you know, have you ever had to like, if you have like baby bottles and they swab it, and then they like do a quick chemical analysis of the swab. And so I'm like, okay, if they have all these sensors that are specifically about picking up hazardous compounds or things that could potentially explode, and it seems like that's what they care about. They don't care about the electronics. They care about things that might explode. So I'm hoping for the best. We'll see. If I have to throw everything away, I'll be all right.
My wife always gets pat down because of baby wipes and stuff. Apparently those look like bombs and they trigger test. The struggle is real.
I gotta say, baby wipes have gotten me out of a couple of bomb situations where kids bombed their diapers.
Dad joke.
Yeah.
All
right.
I think I felt the most awkward because I pulled it out on the plane, and I had this little circuit board and wires coming out. I ended up putting it away. I was worried people were looking at me like I was compiling this little bomb on the plane.
I have felt that way a couple of times when I'm like, I'll open my laptop and just have it in an editor, and I'll like see people like looking over, and I'm like, I mean, this is just what code looks like. I'm not like hacking the plane or something right now. But anyway. All right, well, hope for the best. And then just let me know. I'm going to try to just share my desktop and then go into full screen mode on these slides. But let me know if something doesn't look right. Are you guys roughly seeing a slide there?
Yeah, that looks good to me.
Okay, awesome. Thanks for unmuting. I was like, probably everyone's giving me thumbs up right now, but I can't see.
Yeah, I forgot you can't see us anymore.
Yeah, so just speak up if you have any questions. So the main thing so I put together these slides and gave it at a local Elixir meetup. And my goal there, and kind of the goal of my MPEX talk as well, is just to like, for a long time I was interested in nerves and I just hadn't built something yet. And so I just was interested but had no idea of like one next step to take. And so my whole, like the thing I'm trying to do with Nerves Remote Meetup and these talks is just to say like, hey, you can go build something without soldering, without like gaining a whole bunch of new skills. You can get a project up and off the ground and start using it for something if you want to. So, so the emphasis here is on simplicity and trying to keep the project as stripped down as possible. So our rough plan is that we're going to buy some parts online. We're going to run through a library that's called init or Nerves init gadget, and that will basically get you working Wi-Fi. It works a little bit with your boot process. It gives you an SSH server. When you SSH to it, it's in an IEX session inside of your app, and a whole bunch of that kind of stuff. And so we're going to walk through what that does and how we set it up. Then we're going to hook up an LED panel to our Raspberry Pi, and we're going to manually blink an LED, and then I'm going to show a little bit of a code snippet, but from there it's pretty obvious how you would start to write code to control those LEDs. So buying our parts, you're going to want to buy a Raspberry Pi. I think a great starter board is the Pi 3A Plus. They're $25, and it has Bluetooth, Wi-Fi, all these pins that you can see along that kind of top left side. Those are all programmable pins, so you can read the state of those pins, or you can set the state of those pins and use it to control something like an LED or read something like a button. It also has like HDMI and USB and other stuff on there as well. So once you have that, you can buy yourself a micro SD card. You really don't need a 16 gigabyte micro SD card, but they're actually kind of the easiest ones to find now, because other people need 16 gigabytes to get things done. But most of your Nerves projects will probably be something like 30 to 40 megabytes. So you don't really need that much space, but buy what you can find.
Can I chime in?
Yeah.
Something I learned too is that Nerves actually, when you create an image, creates a limited partition size. So going to your point that you don't really need the 16 gigabytes. So even if you're trying to use it, I can't remember the exact places, but I think the default size is like 500 megabytes. And that's all that they partition or mount. And if you need more space, you have to actually change some of the settings during your build.
Yeah, so by default out of the box, Nerves will just kind of like, oh, we'll give you this much space for your currently active version of the program. They set aside a similar amount of space so that if you wanted to push updates to the device, it'll start to write the new version in a separate location, and then swap which one is active. And then you get a little bit more chunk of space for kind of like disk space that you want to use to save stuff. And I think you're right. I think it's like a total of 500 megabytes is a default, or maybe it's a total of a gigabyte as a default, but in any case, it's small. And yeah, you'd have to change it if you want to use the whole amount. I've never found a use for that so far. So we'll cross that bridge when we get there. Once you got those two things, then I highly, highly suggest buying some of these, what they're called breadboard jumper wires. You can get a pack of like 100 of these that are all like, some of them are female or male or male, all in different colors. And they're just really useful because now without needing to like solder anything or wrap any wires, you can just really quickly connect things like LEDs or other wires to your Raspberry Pi and just connect the things you want to. And since you have multiple colors, you can kind of remember which colors are for which things. So I find those extremely helpful. So now you've spent something like $35, and then the most expensive thing of the whole project is the pixel matrix. So the first one I bought, I bought a strip. I think it had 30 pixels in it, and that one was like $10. If all you wanted to do was something like a status indicator or something like that, that works great. Eventually I wanted to have like letters and scrolling, so I wanted something a little bit bigger, and these are just a little bit more expensive, but essentially every one of these little white things is an RGB LED where you can fully set RGB colors on each one individually and control as they like where they turn on or turn off. So now you're like $60 into this project, but all you have to do at this point is wait. Oh, come on, no animation. There it goes. So now you just have to wait for Amazon to finish shipping stuff to you. That's the most boring part of the project. But once you have your Raspberry Pi and your SD card, you can do this next step. So there's some install steps on the Nerves website, or if you look up Nerves on hex.pm, and that'll go through installing a little archive for you. Once you have that, then you can run this mixnerves.new command, which is just kind of like Rails new or Phoenix new. And you give your project a name. I called mine Lights. And it will go ahead and just kind of make a directory structure for you with a bunch of default dependencies and say, okay, you want me to go ahead and like make the first version of the project? You can just say yes, and it builds. Once that's done, we're going to go ahead and make a few changes before we actually boot it on the device the first time. So we're basically going to add two things. There's this library called Blinkchain, which wins the award for best package name on hex.pm, I think. And that is for controlling these RGB LED pixel things. And so both like strips and matrices and other things. And we're also going to add this nerves init gadget. And if we add those two to our mixed steps, and then in our config.exs file, we're going to go into this init line, and we're going to add nerves init gadget. This is basically telling Nerves that we want it to, right after it finishes booting the Nerves runtime, we want it to boot the Nerves init gadget, and we want both of those to happen before it boots our app. And that way it can do things like go ahead and bring up a network interface so that we don't get really weird random errors about like, hey, there's no network for you to listen to or things like that. Once that's in place, then we can just add a little bit more. You can skip any one of these blocks of configuration if there's parts of it you don't care about, but I'm just going to kind of show most of the main ones. And so first thing you can do is you can configure it to say, hey, I want to have an SSH server on my Nerves device. And in this case, I'm just running a few commands to grab the ID rsa.pub, so my public key that's on my laptop, and I'm just going to point it to that so that it'll copy that into the project and make that be the authorized key on my device. And that way I'll easily be able to get into it from my laptop. Then I'm going in and saying, hey, I do want you to bring up a network interface called WLAN 0. I want you to use DHCP. And then these other configurations for MDNS and node name are just basically how you want your device to kind of name itself. And it'll start up an MDNS server so that you can automatically discover this thing. You don't have to like figure out which IP address it got on your local Wi-Fi. So you're going to create those. And then in my case, I really like to not put my Wi-Fi network name and passkey into my code because I always push it up to GitHub. So I just have those in environment variables, but essentially you're just telling it, hey, I want to configure the default network to be this WLAN 0 and connect to this network with this password. And if you do just that much configuration, this is a little bit of configuration telling the Blinkchain library that my pixel matrix is 8 by 32 and kind of what direction it's in. And I'm using this direction like down, right, progressive, and that basically tells it like, because ultimately each pixel has an address. And so this is just telling it basically like what order the pixels are wired in so that I can paint stuff on them correctly. And with that much done, I set a few environment variables for the network information. I do one more deps get and a firmware.burn. And at the end of that command, you can see it basically created a 32 megabyte thing. It burned it to my local SD card in 2.6 seconds. So, so we're now fully configured. Our project is ready to go. If we drop our SD card into the top of the Raspberry Pi and connect these 3 pins, these are color coded. Pretty much any of the RGB LED strips or matrices you buy, they'll almost always have a red, black, and green pin. Green is the one that's like sending the signal, and the red and the black are the power. And so if you just wire those 3 wires to these 3 things using those breadboard jumper cables, and then you plug it into the wall, you should be up and off to the races.
Is there a specific reason for the GPIO pin you used?
Yeah, so actually going back to this one, sorry, I'll undo this animation real quick. If you look at this pin 12, it's labeled BCM 18, and it says PWM 0. So all these different pins that are there, there's different things that they can and can't do. And specifically on a Raspberry Pi, there's only a couple of pins that can act as what are called PWM pins. And this basically, it means that you can turn them on and off really quickly, like much faster than your code can actually turn them on and off. In most cases, they're only going to be on and then back off for like sub-microseconds at a time. And so in order to make things that fast, there's kind of a special Linux kernel module and some stuff that's happening under the hood that you don't have to worry about. But you do have to know that there's only a couple of pins. So you can also see lower down, there's BCM 13 is PWM 1. And you can also use pin BCM 12 for PWM 0. So you basically have kind of like, you can use 2 of these wires at a time to control 2 different sets of pixels. But you can actually take each of these matrices and you can daisy chain them together. And with the level of speed that is achievable on these PWM pins, you could do something like 1,000 pixels at a time on one of those pins. So, or maybe it was 4,000. Anyway, it was a lot more pixels than I actually have. So, so that's a really great question. Not all pins on the Raspberry Pi are created equal, but all of this was documented on that Blinkchain project. So, so again, it's not like there's not a lot of ways you could go wrong as a beginner here. A lot of the stuff gets pointed at for you.
Awesome.
Does that answer your question, John?
Yeah. It probably would have helped if I've even looked at the Blinkchain repo, but I have not.
No worries.
Shamefully.
No, I mean, people should know the name so that if they want to go do it, they can. But that's about as much as you have to actually remember from this talk. Or I guess I'm not going to measure whether or not anyone remembers anything from this talk, but I suggest remembering that much. So anyway, you plug it in, and if you now plug in this thing, what you can do, you can see that I went ahead and tried to ping lights.local, and that was the MDNS name we configured. And the first time I do it, it doesn't find anything because the device was still booting. And the next time I do it, it finds it, and it shows me what the IP address is. And then if I SSH to lights.local, and by default, the SSH client on my laptop is going to use its public key. And because I configured that to be on the device, it is there on the device. And as soon as I say SSH lights.local, I can get an IX session onto my Nerves device. And if any of you have ever done other kinds of embedded devices like Arduinos or Atmel chips or things like that, I did a bunch of those like in my college years and a couple of years after college, and I would have paid so much money to be able to actually connect to my device as it was running and poke at it, because like when you have a full computer, you have all this ability to see what it's doing and ask it what it's doing and ask it about its state. And if you don't have that, things can be really hard to debug. So going through a little bit of this configuration to get Nerves Init Gadget up and running really will pay like massive dividends. So highly recommended. So at this point, we have 3 of our items done. And now because the Blinkchain library is there on the Pi, and we told it about where our matrix was and the configuration of our matrix, we can run just a couple of commands on the IEX prompt and say, hey, I want to pick a point of 0, 0 and set it to RGB value 255, 255, 255, which is white, and then call Blinkchain render, and you would see the first pixel, the top left pixel on your matrix turn on. And then if you tell it to set it back to black, 0, 0, 0, and render again, you would see it actually turn off. And that's as much code as you actually have to do to start interacting with this thing. And you don't have to worry about all that the stuff that I was mentioning with the PWMs and being able to turn on and off super fast. None of that is stuff that you have to worry about. And so finally, once you want to start kind of controlling it, I wanted to be able to easily type in a message and just say like, hey, just go scroll this across the matrix. So what I did is I have a module in my code where I have a module attribute, and it's a list, and it's a map, and it basically is using the character code. So $A is just a way of saying, give me the ASCII code for the letter A. And then I'm pointing it to this nested list of 1s and 0s, so basically which pixels would need to be turned on and off. So each one of these is like a template of how to draw the letter A, how to draw the letter B, and I have one of these for most of the printable ASCII characters. That honestly, building that list and filling in the 1s and 0s was one of the longest parts of this whole project. So if anyone ever wants to do this, I highly recommend just stealing the code from my repo. I'll have a link to it here in a second. But once that's done, basically whenever I wanted to generate one of these things, I use a couple of functions. And so I have my message, and then I use this message to pixels, where I basically start it off with an empty list of lists, and I pad the left and right hand side with some spaces. And this is just so that the first like frame that I render onto the matrix will actually be all blank. And then as it shifts to the left, my message will appear, and my message will fully fall off of the left side of the matrix before it restarts. And that just makes the animation look a little bit clearer. And then with the things inside of my message, I basically run through and I turn each one of those, I look it up in that map of letter lists, and then I just am basically concatenating those together one by one. And so now what I end up with is these things that look like this. They're just these big, long lists of lists. In this case, I just have one letter. If you look kind of to 2/3 to the right hand of the slide, you can see some 1s in an X shape. And so these are a little bit gnarly to debug on IEX, but this is actually from one of my unit tests, just making sure that it draws things correctly. And once I have that, then I basically write some code that says, okay, now I kind of stored that big list of lists in a struct called a marquee, and then I ask myself, what offset am I at right now? And I grab the width of the matrix and just basically slice off a chunk of each of the rows to give me an 8x32 list of lists. And then I run through and basically for every spot in that list of lists, I turn all the 1s into a color, and then all the 0s into the black color, and then go paint that onto my matrix. So more details, I'm skipping over some stuff because this is not the interesting part of Nerves, but you can always go to this repo. You can go steal my library of which letters turn into which kind of 1s and 0s. let me actually, I'll come back over here. And I will just show you the thing running. So Google Hangouts mirrors my image. So these are scrolling backwards. But this message says, "Hi, Utah Elixir." And then inside of, just behind it, you can see I have the Raspberry Pi hooked up, and I have some little buttons there that are wired up. So I can basically push those buttons to change the color. And so whenever I hit this, what's actually happening is I have another little piece of code. You can see it in the repo, but it's just listening for those button press events. And when it gets one, it sends a message to the gen server that is looping to keep picking the next frame and draw it onto the LED matrix. And so I just send a message to that thing that says, "Hey, change your color." And it just cycles through a few colors. And so some of these are like really unreadable because these pixels are actually quite bright. And my camera is not high quality. But you can do that. And you can also like change the speed. So like the sleep time between each frame. Anyway, so that's the project all working. And again, I hope the thing that can work, or that like the message that's worth remembering, is just that Nerves is not that hard to get up and going with. I really know very little at this point about Linux kernels or how things get written onto the SD card. I don't know anything about that Linux other than the fact that it exists. I don't know anything about the Linux module that actually controls how the ones and zeros get sent to the RGB LEDs. And so it's my point here is that the frameworks and the tools that are available to us actually make it quite easy for a beginner to have an idea, of maybe you wanted to, for instance, like shame one of your colleagues whenever they push something that breaks the CI server and scroll it on an RGB LED matrix in your office or something like that, right? Or maybe in their office.
Please tell me that you've done that.
No.
Dang.
I'm on a very small team right now, and I don't think that it's not ready to fly quite yet. I need a bigger team and someone. I need a Dan Jones, basically. Several people here in the group all know someone named Dan Jones, and they know that he would be okay for me to do that to him. I don't think I have one of those people on my team right now. But so that's it. It's really not that hard to get up and going. And I didn't show this, but actually a little bit later in the slides, because you have that SSH server up and running, you can actually make some changes to your project and send it over the Wi-Fi. And it'll basically build it and then connect to that SSH server using your laptop's SSH key. So it's extremely secure. No one else can push updates to your device, but you can basically just push a new version of your code to it, and it'll load it on, reboot itself, and start running the new version. So it's a pretty amazing set of tools. It's a good development experience, and you can get a lot of stuff running kind of right out of the gate without a whole lot of work. So I think a project like this for someone totally new is probably like a weekend project, right? If you find 8 to 12 hours to spend on something like this, $70 worth of parts, then you're a Nerves developer.
That's awesome. Do you ever think or chuckle to yourself on how excited you get to do simple things like running a marquee of LEDs, and then realizing that's been around for like 60 years, and people have done this, and we have never even been involved or thought about it. It's just been a part of our lives. Yeah, when you can actually do it, it's just the most exciting thing in the world.
Yes, so that's totally true. And there are moments where I catch myself I spent 12 hours to reinvent something that exists as a commodity piece of hardware. But then I took it to so I have a 7-year-old, he's in 1st grade this year. And I took it into his class. The teacher had emailed all the parents and been like, hey, if anyone works in tech, we'd like to talk to the kids about what are sort of tech jobs, or what is that like? So I took this in and I showed them this demo, and I have to say, all the kids thought it was pretty amazing too. And then we did this little example. The kids got to push the buttons, and we did a little example of having the kids arrange themselves into kind of like letter shapes and things like that. And I was the coolest dad in the school for that like 20 minutes. So it's not just me that thinks it's super cool to be able to do LEDs in a marquee. It's also 7-year-olds.
I haven't got to that point yet. When I got my desk working, I went and grabbed my wife and had her watch, raise it up and down, and published to a website. And I was like a kid on Christmas. And she just looked at me and goes, well, why? That's what you've been doing? Yes. All right. Listen, it's cool. Believe me, other people think it's cool. Just go away.
Wife, there's people on the internet who think I'm cool. Trust me.
It's a good point. She has a good point there, Jon.
Well, I think you're both awesome. So
I will also say I have found a couple of practical uses. So this was obviously, like I said, probably the best use case, making fun of your colleagues. But I have built a few other things. So I built an alarm clock for one of my sons who's young and can't read a clock. And so it just turns on different color LEDs when it's like time to stay in bed or when it's time to wake up. That was extremely practical. That was worth a lot of money to me for the amount of time that he spent in his bed when he was supposed to, not waking me up at 5 a.m. And I also, actually, Jon presented a little while ago about doing garage door sensors and controlling garage doors. And a little while ago, one of our neighbors changed their garage door. We don't actually know which neighbor it is, but someone is on like the same frequency as us. Either that or there might be a short somewhere. Any case, there's been a couple of times that we leave and we come home at like the end of an entire day and one of our garage doors has been open all day. And so my wife started getting really freaked out about it, even though we live in a neighborhood where literally everything was still in the garage all 3 times that this happened. And so, but she's freaked out. And so she's like, what can we do? And I was like, nerves to the rescue. So I hooked up garage door sensors. I have it going to a website called home.riesd.com. And so from our phones, we can always check to see what the status of the garage doors is. And if whenever it changes, it sends a push notification to our phones. So there are practical things. I mean, again, I could go spend a couple $100 for a nicer garage door opener. I'm sure that would also suffice and meet all my needs.
That's just not as fun.
Totally not as fun. And do I have any trust that it's not going to get pwned and tell me to go subscribe to PewDiePie next week? Very low confidence, whereas I understand what the actual security implications of my implementation are. So I'm not saying that this is super practical stuff, except for I think there's one really truly practical thing here, which is Nerves is giving us a pretty amazing platform to start developing smarter devices. And I think that there's a lot of evidence that smarter devices are a thing and that there's going to be a lot more of it. And if you look at the traditional tools that people use, like firmware kinds of build setups where they're writing C and then compiling it once for their native machine and once for the device and all this madness, that's a crappy development experience. And people are going to get outcompeted pretty hard when companies start to ship stuff with Nerves. And so if you want to have that kind of a job, actually building your own Nerve stuff is a really good way to learn the bits about hardware that you need to know and prove that you can ship something into production, and then go get one of those jobs. So there's the Nerve stuff you do just because you want to see the status of your desk on the internet. There's the Nerve stuff you do that's like sort of practical, but you could have solved that same problem with money instead of time. And then there's like at least for me personally, I really think that my next full-time job is going to be building Nerves. And so I want to see the Nerves community grow and thrive, and see a lot of employers starting to use it, and then maybe start my own thing as well. So that's my Nerves pitch.
Can I jump in and ask a question while we're on the subject?
Yeah.
I'm kind of running into the same dilemma as for my talk, as far as like what's the angle on doing all this work to make a sprinkler controller, because smart sprinkler controllers they're not ubiquitous, but they're becoming somewhat ubiquitous now. Yeah. And so like the pitch, one of the angles is money, like it's cheaper like slightly cheaper, not even significantly cheaper at this point. And so the only like real good pitch I came up with was the customization. So like adding the soil moisture sensors and stuff like that. And if you have your own weather station, or if you have like really local weather data that you want to work off of, or if you have a particular kind of grass that you know, like want to water more or water less, or if you want to use a photo sensor to like water different parts of the lawn, different amounts based on the amount of sunlight, like those are all pretty cheap components to add. But that's like the only real pitch I think I have at this point is the customization part of it. Because honestly, like for $150, you get like something that has software for your cell phone, and you know it's probably got a team of developers working on it full time and fixing bugs and stuff. So
I don't think there's anything wrong with the answer of just for the pursuit of knowledge, just for the journey of learning, which is a lot of what my projects start out as. Some people, I think it's very healthy to be curious and constantly be learning and progressing, right? Some people have that come to them much easier, or they can just read a book, they can lean it, they can read some articles here and there. But what I found is that nerves has been very motivating for me, especially because there aren't many things that I would be willing to dedicate my after work time or late night time, or time that could be spent elsewhere with family on other stuff. But just this experimentation, and also just to understand better how hardware is interacting around me, and to so the pursuit of learning is enough of a motivation for me, not necessarily for saving money. Because really, if you think about time that you spend building it and the components, are you saving that much? There's been a ton of stuff I bought where clearly if I would have just gotten a marketed piece, it would have been cheaper. But it's really enjoyable. And it's very rewarding to have done it myself and be in control of it myself and make any changes that I want. That's been way cool. There was I thought of one more point while you were talking, but I've lost it. So, I've also have taken a new approach. Like when I see products on the market or stuff that could be available, now I have more of a sense of what's actually going on with that, and can appreciate either what it is doing or what it is lacking and how they might be achieving it. And that's very exciting to me, right? To get more introspection and not just blindly accept, what comes to you, especially as a software developer. When you don't deal much with hardware, like you're very quick, you know in and outs of software in theory, but like how does those ones and zeros equate to something? Like how does a little PCB board equal all this stuff you want to do? There's a lot to open up when you start digging into a lot of that.
Cool. Yeah, thanks. I think, as far as the talk goes, I guess you're in a room full of developers and we're attracted by blinking lights and stuff. So it's probably not that hard a pitch, but rationally speaking, that helps like to rationalize it. And I think like, especially with Mikey's talk, which I'm looking forward to seeing this next weekend, is like having those 5 different things that involve 5 different kind of sets of components, I think is really good to get you familiar with like how the LEDs work and how sensors work. And because like if you find a specific use case that's maybe only valuable to you where there isn't a marketed solution already, that like, oh, there's this sensor and I have one of those, or those are cheap and I know how that works and I could solve this really unique problem for myself with this set of solutions. So at Mastery Connect, we had like one bathroom stall. I might have told you guys this before. We had one bathroom stall for like 100 dudes. And so there was like, there was a constant, like, people going in and out, especially after lunch. And so I built like a little thing with a reed sensor, just like what you're using with the garage door openers, that kept track of the stall doors state, and then sent that out to a web service. And I used like a little desktop app for Mac OS that just had like an airplane, like a dude, and then a dude with a line and a circle around it, depending on if it was available or not, right? And that's not the kind of thing you could buy off the shelf, right? But it was a specific problem that we definitely had, and that like familiarity with some hardware stuff, and made it approachable, I guess. So
I would also, I would definitely agree with all of Jon's points about just as a source of learning or experimentation. I'm kind of making the assumption in my talk at the beginning of my MPEX talk. I'm kind of assuming like I'm speaking to the people, or I'm trying to reach an audience of people who are nerves curious, and at least have like been like, oh, I kind of want to try something like that, and they're just not sure of a good place to start. And so the idea of giving like, it's only a 20-minute talk, so going over 5 projects in 20 minutes is actually maybe a bad idea. So I'm gonna have like 3 minutes on each of them. But the idea is just to show that like here's 5 different things that you can do that are like questionably useful, but that if you wanted to learn this stuff anyway, or you had some desire to just try it out, that here's things you can do, that how much money it's going to cost you, roughly how much time it's going to cost you up front, and that it's not as hard as you're thinking right now. And so I'm just kind of assuming that there's already this sense of fun or learning that people are going for. And that's kind of what, I do hope that I have enough, like maybe 1 minute left at the end to do a quick pitch of like, I really honestly think that Nerves is going to take a huge amount of the market share in terms of people building those kinds of devices. If I had to ship a smart toaster, I would way rather hire a few smart Elixir people than a team of C developers. And, the concerns I would have about whether you have to have really experienced C developers to be able to get to the point where that thing is always going to be able to boot, and it's not going to like get a partial update and then just never start again. You're needing to ship replacements to people. Like the problems of an embedded device are truly difficult problems to solve, and making them secure is a difficult problem. So I just keep thinking more and more that as all these products are starting to head up to the market, and as people are finding them useful to some degree, Nerves is just in the optimal spot, other than the fact that it's relatively still a young framework and a bit unproven. But that's just a matter of a few people using it and starting to ship stuff, which is already happening. And so it is already becoming a proven production platform. And now that's off the table, and you just have the fact that you can get more stuff done in Elixir than in C. And if someone wants to have that debate with me, then I don't know that I'm interested in engaging in the debate, but for me, that's not a question. Like, as a group of Elixir developers can ship more stuff than C developers.
There's also the idea that you don't know future use cases, right? Maybe all these small projects that are useless will equate to knowledge that will be useful when there actually is a product or something to do. Or just,
I think
like you're saying, that familiarity.
If you look at Connor's whole life, basically, his whole life is building things that are seemingly trivial, right? Like, what's the purpose of that? And it seems like he just has a really good time, like challenging himself to do things. But also he's like one of the people working on like one of the biggest production nerve systems, and probably how he got to that point was doing all of that, like just weird stuff to challenge himself.
So I have like 7 different ideas on projects right now, and I've had several conversations with Connor, and it's so funny every time, because I'll ask a very simple question. I'm just trying to like get my bearings, figure out which direction to go, where I need to start, and he'll just reach out, we'll chat a minute, and then he'll come to, well, what are you trying to do with this? And I'll tell him my exact plan, and almost every time it's, oh yeah, I've done that. This is what you need. Like my latest one was trying to control my fan, which uses a radio signal remote. And so I was just asking radio questions. What are you trying to do with it? Yeah, really? I just want to turn my fan light and speed on and off. He just laughed. Oh yeah, I've already done that. This is what you need. Boom, 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 boom. So
yeah, and I mean, if you imagine yourself as like someone who's trying to start a company to build a smart device, dude, there's no one in the world you'd rather hire than someone who's just experimented with a whole wide array of that kind of stuff and then shipped something significant to production, like needing to have the devices hardened and the boot process is exactly set up and it recovers from failures correctly and all that kind of stuff, right? Like if you can find that candidate, that is your dream candidate. So yeah, I think you could definitely make that part of your pitch depending on what your talk is about. But yeah, I think if people are actually like have some desire to like, if they have just a little bit of desire just to play around because they've just never done hardware before, or if it's like, hey, I've done some hardware and I actually really enjoy writing code and then watching it do something in the real world, I'd like to do more of that. I'd like to consult for those kinds of companies, or I'd like to work for those companies, or I'd like to start one of those companies, then, you know, working on Nerf stuff is like a major value proposition.
Well, I need to get going, but thanks so much. Like, I really enjoyed the talk, and I think you really accomplished your purpose of like getting people excited about using nerves. I think I'm really excited to try that out, and so yeah, I think it's gonna be great.
Awesome. Well, Dennis, thanks for coming and hanging out. We'll catch you again in the future sometime.
All right. Yeah. Thanks for having me. See y'all.
See ya.
Yes.
Jon, do you want to just give us a quick run through of how your desk stuff is going?
Sure. I don't really have fancy slides. I mean, I did a whole write-up already.
Yeah, let's actually just mention that. What's your blog? Like the main address for your blog?
So it's on Embedded Elixir, embedded-elixir.com. And that's actually
going fancy pants.
Well, it's not mine. That is Frank Cunliffe's blog that he kind of posts stuff about using Elixir and hardware, and subsequently ends up having a lot of Nerf stuff on there. So I just thought it'd be fun to put there with some of the other articles.
So did you write it like explicitly for that blog? Or did you just contact him and he just wanted to put it on there or something?
It's just an open source project. So if you want to write on it, you just make a pull request and then they review it, tell me all my grammatical errors, and then post it. And it was actually funny. So like, yes, it's a fairly useless project, but there were a couple cool things that I learned on there. And one of them was during the review from Frank. So I ended up adjusting my article and even some code in it based on his review.
Nice.
Like,
dude, so what you're saying is if you have a Nerves project and you want some feedback from an expert, you just try to publish a post about it on embeddedelixir.com?
Yeah, really, this is the time to capitalize, because all these Nerves core members are just on top of it and commenting on everything. So, I mean, just like you're saying, if it's going to get way more popular, we're going to lose that. There's no way they can keep up. I don't even know how they keep up now.
Yeah. Actually, Todd, are you going to be there on Friday for the Nerves training at MPAX?
No, I'm going to be down in Irvine at work for the training. I'm going to do the training at Lone Star instead.
Oh, yeah.
Are you going to do the training?
They didn't announce the training until after I had bought my tickets, so I get in at like noon on Friday. I think it starts at 10 a.m. And so I'll probably be a few hours late. But yeah, I was gonna maybe tweet at one of those guys and just say, "Hey, I'm gonna be a few hours late, but I'd love to jump in partway through if I can." I mean, hopefully with the Nerf familiarity I have, I can catch up to where they are. But if not, at least I'll sit in on as much of it as I can. But so let's make it an explicit plug. Go to embeddedelixir.com. Actually, as I was I just pulled it up and I was looking, and there's almost all of the recent blog articles are things that I've either read or heard about recently, and I just didn't realize they were all on the same log. And so if you have any nerves affection in your heart, this is a really good place to go read up on it. So good call on putting it up there.
Yeah. I mean, I debated putting on Medium or something like that. That may be more public known, but I like supporting the nerves guys, so went for a beta Elixir. So I won't go over the whole thing, but I guess if anybody hasn't seen it, the gist is I used a Raspberry Pi nerves to control my standing desk, and then also intercepted the messages to get the current height. And then I published that to a website for no reason. But there's a breakdown in how I kind of reverse engineered, looked at this. Mine uses this RJ45 jack Ethernet port, and I use a multimeter to actually figure out most of these wires, and then kind of some trial and error based on what I saw on the board. You can't see in this picture, but on this board, there was a T and an R on two of these wires, which I assumed was transmission and receive. And I was right. So that's where the messages were coming from. But the coolest part about this was when I initially hooked this up to nerves, I use the circuits UART library even on my machine because it's a cross-platform. I could get messages. When I was using Screen, this just looked like garbage. There was weird non-Unicode characters and repeating letters, and it was I felt like I was going to have a chore going through all this. And then when I started using UART and just getting them straight serial, I would get messages like this, which still didn't quite make sense, but at least it was more clear. I ended up figuring out that they were in groups of 4. They're in the UART library. You can actually frame it 4 bytes at a time so the messages look better. And so this is the part that Frank pointed out. In fact, after he merged it, he comes back to me and sends me a message. Hey, I actually saw this and you're doing this, and it could actually be really, what do you call that? Refactored. Oh, cool. But I have this notepad just full of scribbles and attempts and math to figure out what these messages were meaning and how they were getting the height out of it. And essentially, you have these 2 bytes at the end. Like these 2 ones in the beginning were basically useless, or I just don't care about them. But at the end, you would have these 2 bytes, and this last number is the current height in kind of a decimal form from binary. So this number right here shows my desk is 25.5 inches tall. If you were to take this last number divided by 10, that's what you would get. But then this 0 right here, because you can only have 255 bits in a byte, or 255 is the highest decimal you can represent in a byte. But my desk obviously goes higher than 25.5 inches. This one becomes essentially the starting place. So if this were a 1, and I kind of go to it down here, if this specific byte is a 1, then you're actually going to start at a base of 256 and add this number onto it and then divide by 10. And so I actually had kind of crazy math and stuff to do that. Not crazy math, wasn't that bad. But it's actually called, and I'm going to butcher this, endianness. And this is what he pointed out in the MR. So I was like, well, what the heck is endianness? And I go and look. And the endian signifies where the most significant byte is in a binary representation. And in this sense, this is big endian, which means the most significant byte is at the end. And all the other bytes are markers or additions that basically, if they exist, you're adding that amount of the number, like 256 or whatever the highest number for that a byte can represent there, onto your most significant byte. Which would have been cool when I was doing this. Probably would have saved me a few hours and countless scribbling on a notepad. you know, the entire thing could be summed up in one concept that's already been defined that I've never run into.
So
but it was
can
cool.
I ask a quick question?
Yeah.
So the last line on the thing that you're hovering on right now, where it says heights size 16, was that the thing that Frank mentioned as like a refactoring?
Yep. So what I was doing is taking these numbers and converting them to strings and adding them together and making decimal places and whatnot. And so then Frank sent this out and he goes, well, Elixir and binary matching can actually do this, and you can give it a size of 16. So you can pattern match the last 2 bytes will be added together in this height. And so that height would then become this 309, 306, whatever. And then you can just divide it by 10 and bam, you have your current height. And if you actually look at the help page, I wonder if I can, hey-yo. So you can do help on a string binary.
What?
And it actually talks about, where was it? And this is funny because I just ran into this today. Oh, hold on. I skipped it too fast. There we go, endianness. It has a section about endianness and how you could handle it in your binaries and how you can even pattern match on it. And because Elixir, Erlang, VM is so efficient on pattern matching, this was just like a huge win. I don't even need performance out of it, but obviously I got it there now.
That's actually really cool.
Yeah, this one was exciting because I really wanted to try interacting with something that already existed in my house. You know, we've done a lot of Nervous project making controllers, and we're buying sensors, we're buying relays, you know, we're buying all these things that have specs and we're manipulating it. But I wanted to do a little reverse engineering. I wanted to see if I could take something in my home and interact directly with it, figure out how to do that. So that was ultimately my end goal. And even though the end product is kind of useless, I think that this brought a lot of cool learning and knowledge and things to look for. And I mean, in the process of this, trying to figure out how to get these UART messages, I was using different USB to TTL hardware and drivers. And so then I ended up making my own nerve system that enabled those drivers so that I could use all these different USB to TTL wires, which, spoiler alert, if you get a new one, a new USB to TTL, and you're trying to go over UART and it's not working, that's probably what you have to do. Probably some driver you gotta go in and do, enable and rebuild. So that's pretty much it.
So I have Dude, Where's My Desk pulled up right now.
Oh yeah.
Can I actually, hold on, is it okay if I share my screen and then make you?
Yeah, I'm gonna stop my screen share.
Dude, we gotta have the payoff.
Here, I'll show you also, this was another cool thing that I did. So I bought these, I don't know if you can tell, at Home Depot or Lowe's or something. You can make your wall outlets with a bunch of squares and you put a bunch of different ports in it. They're modular. And these are Ethernet, RJ45. You can put wire on it. And I don't want to move it, but what I did is, because if you saw the end picture, I had all these wires coming from a cut up Ethernet cord and going back to my controller because I want to use both. But I ended up taking one of these little ports and then wiring it so that I could just plug my controller like into it and then plug all that into the breadboard.
That is awesome.
Here, maybe I'll just try to get to it. Can you see this little wire setup? Okay, so now you have the desk. You have the website open.
Yeah, here, I'll share my screen. I have the website on right now. You're at 25.6 inches.
Yeah, you ready for me? I'm gonna hold the button.
What? Oh, dude, look at that CSS animation.
It's not CSS. This is using Drab. This is all on the back end.
Oh, nice.
Now I gotta stand up, guys.
And I guess it's really only animation because it just keeps updating.
Yeah. I guess it kind of is like CSS, but because it's
50.9 inches.
Ta-da.
I still think your URL should have been howhighisjon.com.
No, yeah, this is. I like the choice I did. Yeah, it uses drab and it just changes. I guess it changes the style of that element to make the legs bigger, because I'm obviously such a good front end developer.
Hey, I don't think we've seen any Phoenix front ends that Todd has made yet, but I'll say you don't have any competition from me. My garage door openers literally just change a color. They're just like boxes on the screen, and they change color when they're open or closed.
Yeah, it's not a competition.
That means Todd thinks he's going to win.
No, I don't know. I don't even plan on doing any Phoenix front ends. At my work, we don't even touch the front end. I don't even have the front end repo cloned on my machine for the project I've been working on for the last 7 months. So,
oh, that sounds amazing.
That's how divorced I am from that.
It was that way at my last job, and at my job right now, it's not that way. The team will need to grow a little bit more before I can completely forget about JavaScript again.
Blessing and a curse. There'll be 8 frameworks in between the time you forget about it and have to do it again.
At least.
Hey, Jon, do you think you could do a pass-through on the Ethernet? Like, it seems like you're doing kind of a splice, like where you're reading it, like your desk is reading from one side of it, and then your Pi is reading, like it's splitting the signal. Do you think it would make any sense to do a pass-through, or do you think it's even possible where your Pi would take the data and then spit it back out the other end, kind of? Or is that worthless?
Yeah, actually, I could.
Yeah, it might be kind of interesting if you have a 0W and then you have, it's mounted in line. It could be like basically no jumper wires present. Might be kind of neat looking.
Yeah, I wonder. I don't know. That's probably a good idea to try. But to be able to just plug Ethernet straight in and be able to read the info off of it, probably would take a lot of work though for figuring out how to get UART stuff from Ethernet.
Yeah, I'm not. Yeah. I'd be curious to know, like, would a standard, because I think from what I understand, most like network cards basically only know how to speak the protocol that they're expecting over an Ethernet cord, like the TCP/IP stack, right?
Yeah.
And so the fact that they're using those pins in different ways, not necessarily the same way that an RJ45 normally would, I wonder if it would actually even show up as valid packets, or if your network card would just be like, I don't know, someone's yelling about something on this network, but I don't like. I wonder if it would just throw that away as noise, or if it would actually look like packets because it would have to then, I mean, for it to parse it as a packet, it would have to guess an IP address. And I don't, anyway, it'd be interesting.
I mean, I guess in the very least, what you could do is you could take, like I have, that little Ethernet jack and then wire it or to a spliced USB cable that goes into the gadget port of the Pi Zero. Because then you don't have to deal with drivers or anything. You just have to make sure the right wires are going to the right ports or pins on it, right? Maybe I could get that to work.
Oh, you're saying to stick it to the UART on your Pi?
Right. So the Pi Zero, that second, man, it's so dark. That second USB port is the gadget port, and that actually will read serial communication. So if you plug that into your computer, then you don't need any other TTL USB cable. You just plug it in. So I guess the question would be, could I splice a USB cable together, sends the messages over that USB to the wires of the Ethernet? maybe.
That'd be cool. I mean, if it works, I would love to hear about it for sure as a follow-up. But as a quick kind of, because I have to wrap up as well. Is anybody here currently working on projects that they want to give a teaser of, or any topics that you're interested in hearing about in the future?
So I have been doing. Sorry, I'll let Todd go next.
No, all I'm doing is working on my talk and building out like a little plastic case, like that's all wired, and I'm adding toggle switches to the sprinkler controller and some LEDs so that you can like manually deactivate a zone. But yeah, just something visual that I can bring with me to show people what it could look like. But that's all I'm working on right now, and to say I'm even actively working on it is almost a farce because I've just been stalling. So sorry.
So I have been really interested in radio and nerves because a lot of sensors that you can buy just use simple radio signals, radio frequencies, like my fan remote, a lot of door sensors, magnetic sensors. And so I wanted to see if I could replicate that on the Pi. And then I wanted to see if I could replicate that in nerves. And I found this library called, it's just RPI TX, so Raspberry Pi transmit. And the dude has written stuff so that you can transmit from your Raspberry Pi up to 750 megahertz from a single GPIO pin. So this is my radio antenna, which is just a breadboard wire. And this is what I was using to transmit to turn my fan off and on with nerves. And I'm super jazzed about it. And and then I got it to do my car, so I can unlock and lock my car. And and I'm sure if I could do the car, then that means I could do the garage door too. So then I can use this little Pi to open and shut my garage door, and I don't have to have the wires coming out for all that stuff. And then if I get magnetic sensors, then you don't have to have wire for the magnetic sensors to get that detail anyway. So like opening up radio on the Pi and with nerves is really exciting. And I hope to get like more concrete stuff. But what you have to do is I had to compile this guy's stuff and then export this binary command, or this binary for it, for sending these signals. And then I basically just I put it on the Pi, I put it in the nerves image, and I make a system call out to just run it with its command line arguments and everything. And it replays a radio signal. So it did also require this, I guess if you're curious. For these specific things, I needed this RTL-SDR, which is a radio-defined or software-defined radio USB dongle. And I've got an antenna over there and everything like that. But what I did is I just plugged that in my computer and I recorded me clicking a button, like clicking my remote or clicking my car remote. And then what this RPI TX library does is it then takes that file, that recorded transmission, and just replays it and transmit it out. So all I'm doing is copying signals that are being played. The next step is to see if I can like decode the signal, and I can, you know, I don't have to be required to just replay all the time. I could just send out what I need. But it's cool because like a smart plug that's fully integrated and all that jazz is usually $50. Or you can get smart plugs that have a dongle with like an on and off button. You can get a pack of 3 for $15. And you just copy every signal for the on and off for each of the plugs, and then you have a whole remote setup, right?
So does that library record the frequency and everything? So your radio can broadcast to a bunch of different frequencies?
Yeah. So this can broadcast up to 750 megahertz, and most in-home stuff is, or a lot of what I've seen is like 400, 430. Like that's what my car remote is, and the fan remote and everything like that. So it's easy to record and replay. The recording is a different library. that you do with this radio software-defined radio dongle?
I know of some devices that use 900 megahertz for kind of in-home stuff, which seems to kind of be. I mean, that's the highest megahertz I've heard of, short of like getting into like 2.4 gigahertz stuff, which gets used for baby monitors and Wi-Fi.
Mm-hmm.
But yeah, so it seems like anything that's under 900 megahertz, this thing probably is handling all that. So, and then if you did want to actually use that software-defined radio dongle, I'm guessing it probably has like a more full range of frequencies and stuff like that.
So this one that I bought was $25, which is like, they can get way expensive, but it only receives, it doesn't transmit.
Oh, okay.
So that's why I was so keen on getting my Pi to transmit without extra hardware.
I mean, I'm keen on it just because I don't want to go buy. Yeah. I don't want to go buy another USB device and then figure out what driver I have to modify my Raspberry Pi to have loaded, and right, like that's a whole can of worms if you really need to go all the way that level. So that's really, I think that's super cool, and maybe that'd be an interesting project for to try. Like I was looking at how the Blinkchain library wraps another existing third-party C library that is written for like, hey, if you need to do PWM stuff for the sake of controlling RGB LEDs, there was a C++ project, and then Blinkchain basically wraps that with Nerves Make, so that it's like, hey, you can install Blinkchain on your laptop or on whatever, and it will compile and get you the right binary version. And then they have a little, I think he also runs it as a port, and so you're sending and receiving, and he has a little bit of that logic for like, oh, if I get this information on the standard in, then I'll call these library functions in the C library. And so I wonder if we could do something similar, just to make the integration smoother for other people wanting to transmit from the Pi.
Yeah, and yeah, I thought about that too. I just haven't learned enough about how to port stuff and do it, but I figured there's going to be possibilities. I was just really excited because I thought that I was going to have to create a custom image, bring all the libraries in that this guy's using to compile it, and do it as part of the build process. And as I was going through all this and trial and error and kind of banging my head, I thought, I bet I could just take this binary and just run it from anywhere as soon as it's compiled. And yep, sure enough. ran it from there, ran it from my Mac, ran it from another Pi. It's a piece of cake.
Yeah, it's not making system calls and that kind of stuff. Well, I'm sure it's making some system calls, but not like platform-specific system calls, maybe.
In theory, you could sit outside with your laptop and record your neighbor opening his garage door, right?
Yeah, for sure.
And then just troll him as much as you want.
Mm-hmm.
So maybe I have a neighbor doing that, which is why I had to set up garage door sensors.
Yeah. It's definitely interesting. You can most radio modules you can buy are pretty cheap, but they're like module to module communication. You only know how to communicate with each other. So that's why I was really interested to see if I could replay, because again, I wanted to see if I can interact with something that already exists in my house. But if you are making your own components or stuff, you're probably buying those. A pack of 5 that have a transmit and receive was like $10, and they're really low power, and you can make really low power sensors to do the stuff you want in. Zigbee uses 2.4 gigahertz mesh, and so having a little Zigbee dongle, you can interact with a lot of existing, home automation products and stuff too. And that's probably down the line, but like I think there are some use cases you probably wouldn't want to use this for, but for what I needed, like a really quick and make it happen, it's been perfect. Requires a good amount of setup though, with this whole having to record it and replay it.
Did any 7-year-olds or maybe your own kids be like, oh my gosh, that's amazing that you can turn on that fan?
So no, my wife rolled her eyes again. I I don't know why I just didn't take my laptop, but I had my laptop here, and our room is the complete opposite end of the house, literally the farthest point from me. And so I would run it, and then I'd get up and walk out and see if it turned off. And then I'd come back, and I'd run it again and walk out and see if it turned on. So I finally had my wife, I said, look, give me your phone. What do you need it for? I just need it. And I FaceTimed her, so I kept my phone here and her phone in the room. And when I got done, I gave her phone back. She said, what do you need that for? Oh, I was turning the light off with my Raspberry Pi. She rolled her eyes. All right. The watch it was turning off and on.
That's amazing. I thought for some reason, I thought that garage door openers actually used like a rolling code or something like that so that you couldn't just replay. But maybe that's only nice garage door openers. There must not be that great a security on mine. Otherwise, it wouldn't be randomly opening.
Yeah, my garage door is from 1995, so maybe it won't work on the newer stuff. Or maybe, like if you're replaying the whole message, that rolling code counts still. Maybe there's no term of life for it. I don't know.
That's the kind of thing though that I was imagining. Like that would be cool for me to like know what's the actual security of my garage door and be like, well, I'm changing it. I'm going to make it so you have to like, you have to like provide some authentication somewhere, and the code running on your phone or something is actually going to generate like a signed key, like a JWT sort of a concept that has an expiration on it and it's signed with some key, and then like no one can replay that, right? Or else if they replay it, it's only going to be valid for 5 minutes or whatever.
Yeah.
And that kind of security would be awesome to have. And I'm sure that that's not what my 1990s whatever garage door opener has on it right now. But then like the first time we moved in, I had to buy new garage remotes for my garage door opener, and they were like $45 for 2 of them. And I remember just thinking like, how is this $45? Yeah. So anyway, that'd be cool. Like in a way, I'd almost like to start to disable some standard stuff in my house and make it like the same kind of security that has to be there for banking software and standard internet fare.
Yeah. There's also lots on the internet about how you could record a signal and jam a portion of it so that it doesn't care about the rolling code, or jam the rolling code so that it still gets through. I was reading up on some of that just out of curiosity in case I had to do it. I think everywhere that says this has the caveat, it's for learning purposes only. So maybe I should like clarify. And technically in the US, the 433 megahertz band is completely illegal to broadcast on. So if you're like broadcasting across the state at 433 megahertz, then somebody's going to come talk to you. But in your house, it's cool, apparently.
I'm guessing that the Raspberry Pi probably won't go statewide.
Yeah, well, so my remote, I don't know, man. Probably not, but my remote couldn't even turn it on from here. And I put this little cable on, and bam, suddenly had range.
Someone's going to come to your house, sir, you need to trim that jumper.
Yeah, so I have no idea how far this is broadcasting right now. But it turns my room on and off.
There's another Google Hangouts right now with the dad from somewhere in another neighborhood that's like, dude, my light just keeps turning on and off for no reason, and I FaceTime my wife, and I don't understand.
Yep. There's me.
Sorry. All right. Well, I think that's probably a good time to wrap it up. I don't have any other. I'm similar to Todd. I'm just working on conference talk at this point. I think after that, I might go through these 5 different projects that I did, and maybe I was thinking about doing write-ups and putting them on my blog, but maybe I'll put them on Embedded Elixir as well. It could be a good way just to, I don't know, just provide more beginner-friendly content in a place that people will know where to find it. So anyway, awesome. Thank you, everyone, for your time. It was good to get together again. Todd, I look forward to seeing you at MPEX. As I said in our group chat, I'm super glad that I'll know at least one person there. I get really bad. It's not a great thing for a speaker to have, but I get just bad like social nervousness.
Oh, that's going to be bad. I don't want to spoil this for you, but one thing I considered for Lone Star is that it's single track. And so like when I did my Hex talk at ElixirConf, I was like, all right, well, there's 3 tracks. So only the people that really care about it will even show up, right? And so like, but then I was thinking, man, if it's single track, people are going to have to just sit through my 40-minute nerves talk, even if they hate it or if they're not interested in it at all. So sorry, Mike. I'm sure they'll love it. Frank will be there. Justin will be there. I'll be there. So we'll be supportive.
Yeah, I'll have some friends. I am kind of glad the fact that it's a single track, but it's only a 20-minute talk. So even if someone's like, hey, I'm here for like beam knowledge, not for nerves, it'll just blow by them in 20 minutes and they can move on with their day.
You could also bring back your Roombot Twitter bot.
That'd be a fun project to bring.
Debut that again and have it just take pictures with the sentiment captions on Twitter again.
Yeah, that I would have to probably update it to be nerds. So the code that it's running right now is like this weird mix of Raspbian. There is an Elixir process running, and then it has some like Ruby glue code. Dude, that thing is a Frankenstein of code, but it was so much fun to make.
Yeah.
All right, hey, Mike. One question for you. Maybe conference. Where are you staying?
It's just at the conference hotel. Because I was a speaker, they just automatically gave me a room that's at, I forget what it is, but it's with whatever the one is that's on the website, I think, for MPEX LA.
Oh, okay. I'll check that out then. Okay, cool.
I'll DM you my room number once I know that.
Okay, I'll figure it out. I'm staying in downtown on Friday and Saturday, and I'll be at the speakers dinner on Friday. So
nice.
I'll catch up with you on Friday when I'm heading up to LA and see where you're at.